Bismillahirrahmanirrahim. Greetings. This is going to be second video lecture of a mini-series about the concept of rate, ratio, and proportion in mathematics. Now, in each video, I have provided the site link of the previous one, and I do encourage you to watch this mini-series in an ascending order. So let's get started for today's lecture, shall we? Okay, this one I don't have to zoom it, I read it for you. You can always write them from my words, but the other ones I may zoom them for a better readability in a sense. It says that this is a problem. It says that an institution has 25,410 student enrollments. And it includes freshman, sophomore, junior, and senior levels, all right? They are in the ratio of 4 to 3 to 2 to 1. Now, he's asking, determine the number of freshmen, the number of sophomore, the number of junior, and the number of senior students in that institution. Now, I haven't the faintest idea how to begin. I know about the ratio and the rate in a fraction form from previous lecture, but I do not know what the colon stands for, so we go and start to answer these questions, these two. So let's do the former first. One of the strategy, a good strategy in mathematics solving problem is that whenever you encounter with a problem that seems very difficult to begin, as I said, I haven't the faintest idea how to start, always try to make an example, which is much simpler example, of your own, that you already know the answer, and see the way that that answer can be achieved. You can guess the road that can take you to that answer. Do you follow me? And then you can use that method that gave you the answer of that problem that you already know the solution. You can use it for the harder problem as a jump start in a sense to solve that problem. It's a very, very good strategy for beginner and intermediate and even advanced students. Okay, then let's get started. Number two in this question is that what does the colon stands for? I'm familiar with the ratio. So I have made some examples that I give and I zoom it for you, stay out of your way, and we simplify that colon but notation for the ratio. And then the following lecture, I'm going to go and find a simpler question so that we can solve this hard problem. Okay, let me now hang up the second one and zoom it and stay out of your way. My apology for the primitive equipment I have, but I'm conveying the message anyhow. Now let me zoom this one if I may. I stay out of your way. Now suppose that Mr. X is hired to work in the kitchen, and the chef tells him to go and mix 1 part of flour to 2 parts of sugar and the party gives them container and then bring for him. No, that could be 1 cup of flour to 2 cups of sugar, or could be 1 bucket of flour to 2 buckets of sugar. That is what the unit in a ratio is in material. He says in the ratio of 1 to 2 in this form. So the guy who was hired, he goes and do that, he mixes them up and brings it and give it to the chef. Now, the following day, the chef asks the same kind of question, but he adds to that a third ingredient, and that is, he adds to that, let's say, water. Let me see if it is zoomed good enough. Okay. Now, he gives him this handout. He gives him and he says, go and mix flour to sugar in 1 part of flour to 2 parts of sugar, whatever the container is as a part, and then sugar to water 2 to 3, and flour to water 1 to 3. Now the guy goes and mix up 1 bucket of flour to 2 buckets of sugar, let's say his bucket is using, and then he adds to that 2 buckets of sugar to 3 buckets of water, and then he adds to that one bucket of flour to 3 buckets of water, and brings it to the chef. And the chef fires him. The poor guy loses his job. That is Mr. Rogers' make-believe kind of a story. Now, whenever there is ambiguity in mathematics, mathematicians are very good to introduce definition to filter away that ambiguity. That's what all definition come from. And then also they are very good for inventing notation. And sometimes the notation also contribute to the concept. Like when you take derivative, when you take calculus, you will see dy over dx, that is the notation invented, introduced by Leibniz, contribute to the concept of the derivative, the notation itself. Now, the colon notation has been adapted kind of universally to stand for the word 2 and stands for ratio, that we are going to see that. Now, look what happened if the chef would have given that Mr. X, that poor guy who was fired, let me zoom this one to see if it is readable or not. Yeah, I think it's good. Now, no, this is what the chef gave it to him. Is that right? Let me cover this one. He gave it to him and the poor guy messed up. Of course, for a person who is familiar with this notation, this one, he would have not made that mistake. But for the beginner, this recipe that the chef gave to him is a bit ambiguous. So the poor guy was really innocent for he made an innocent mistake in a sense. Now, if the chef would have given him this way, he said, go and mix flour to sugar to water in the ratio of 1 to 2 to 3. You see the word 2, colon stands for that. Colon stands for the word 2 in English language. And then the poor guy would have not made any mistake. He goes and mixes whatever the container is, 1 part in flour, adds to that 2 parts sugar, and adds to that 3 parts of water, and brings it and give it to him. So you can see this notation has much better advantage and makes the subject much easier and comprehend than the previous one, this one. And also, as I have written here, if you want to take a note of it, it's important, this notation will have also other benefits that we will be seeing in the coming lecture. Okay, let me now zoom it back. Now in the coming lecture, I'm going to go over, as I already mentioned, make an example of my own so that the problem that we started with, we can solve it and see how easily we can do that with the strategy that I did recommend. Okay then, I thank you for watching, and as always, I wish you all prosperity and good health, and please stay and remain in good health. So long.